So now we can go back to the first DSL example that I showed, which was the testing one, and see how dynamic variable works in this case. So the problem in this example was the creating and disposing of this workspace object without the client code having to handle that itself or having to refer to it. So we created dynamic variable for the workspace. This is very similar code for the test language method to what we had before, in that it has the try finally in order to handle the dispose. But the workspace, the with value method on dynamic variable is taking care of making that value available through this method, the run method. In order to keep the DSL short, I want to avoid having to refer to the workspace explicitly, and I want to avoid having to call the value method on the workspace explicitly. So I could have made run a def there, but the most concise way to do it was just to make it a function object. So now all of the boilerplate has dropped out of this example, and then I've reached the goal that I was hoping for. Any questions on this example? In the previous example, I wasn't really using the stack nature of headless words, of dynamic variable. I was just setting a value, and then when it was done setting, return to null or none or whatever the default is. In this GUI example, I actually get benefit out of the stack nature. I define a class called context, which has a reference to the parent object being created. So if I'm in the code for creating a menu item, I want the parent to be the menu. If I'm in the code for the menu, I want the parent to be the menu bar, and so forth. So here I'm using option rather than null, and we use the usual trick of having the body of each of these methods be by name. We use context with value in order to grab the current context, and then and restore it when we're done. So every time we make a new context, we store the value of the current thing that we're creating. So to keep the code short here, we're only getting access to one parent, but you could also imagine having the context objects be changed so that you could get to all the parents if you needed to. Any questions on this example? Yes?
I have a question about the previous example. What exactly did with value give you again?
Well, let me go back and show the previous versions that we were trying to fix. So the simplest version here with just plain use of a closure, I have to, the first red part is having to give this workspace a name, and then having to refer to it every time I call something on it. So that has gone away. And in this other version, where we used implicit to get rid of having to mention it over and over again, we're still having to mention it once. that's all I have. I'll send slides out to the list. I'll send a runnable code, and the slides actually, this says the end, but this is not the end. There's actually like 3 or 4 slides more of details that I thought were just like too detailed to present. But if you look at the slides, you'll see some extra additional stuff, like what the difference between thread local and inheritable thread local is, and so on.
So apparently you'll get more questions by email.
Pardon?
Apparently you'll get more questions by email.
Right, and I'm also happy to take any questions on any of that now. Oh, you know what? One thing I meant to talk about was the kind of the status of this in the Scala standard library. This is not very official stuff. I mean, it's just like a 15-line wrapper. The way things go into the Scala standard library currently is a lot more rigorous than the way stuff went in like 6 years ago, when it was pretty much just Martin and his postdocs and graduate students using the language. So this was just like someone in Martin's lab saying, "Oh, I'm going to stick this in. This is a neat example of something." But it's not the most general purpose thing. You can imagine all sorts of improvements, like offering you a choice between the 2 different kind of thread locals. There could be some sort of built-in support for doing something better with the uninitialized state than using null or forcing you to use option. Rather than thinking of the standard library thing as like, oh, it's in the standard library, I'll use it. I would definitely think of it as, oh, here's some sample code. I can either use the one that's there if I like it, or I can just copy it and either subclass or just rewrite it however I want, because there's not that much to it.
So you actually mentioned about thread local inherited thread local, and you mentioned that there is a difference continually with
Yeah. As long as you're writing single-threaded code, as long as you're not spawning new threads, then you don't see the difference. But the difference between thread local and inheritable thread local is if I spawn a new thread, does the new thread get the value of the parent thread, or does it revert to the uninitialized state? So, an example of when this matters is, well, so for example, suppose the resource that you're storing in your dynamic variable is like a database connection, or like in the testing example, some resource that's going to need to be disposed. If I spawn a new thread, I might very much want that new thread to have access to that resource.
So you make it
so then I would make it inheritable. But if I do that, I need to be careful that the new thread that I'm spawning doesn't outlast me, right? Because when I the parent thread exit, that resource is going to get disposed and reclaimed. So, and there's no checking for that. So it's, if you want the inheriting, that's you just have to be careful.
And moreover, doesn't it can violate the notion of you're controlling when the value changes by going up and down, by creating and exiting stack frames?
If you inherit?
Yeah.
Yes, absolutely. There's no checking whether you're doing that correctly, and I think the condition is does the child thread outlive the parent? I actually don't know why the author of Dynamic Variable, Lex Spoon, chose the inheritable choice. I think I'm gonna send him an email and ask like whether it was whether there was thought behind it or whether it was just like, well, I need to pick one. So
there's one other caveat on sort of thread local stuff, is that the existing thread local has issues if you use a whole bunch of them in your code. There are various safe versions of thread local out there that even still apply after the Java 5 improvements to thread local.
Okay.
So dynamic variables built on the one that has the bad leaking behavior. So be warned.
okay, I'll ask you afterwards.
If you use a whole bunch of them,
for
it's
like
fine.
a
Yeah,
link
I'll
on
give you the
that,
reference.
so I can include that when I send out the slides.
Sorry,
Yes.
perhaps I'm being a little obtuse. Could you go back to your, the test code example, and just, and talk a little bit about how in your actual code in green, how that code down there picks up the things that it needs.
Sure. So here the dynamic variable object is, it's global to this slide, right? It's either stored in some singleton or it's just defined in some enclosing scope. In that same scope, I have a function value which is stored in run, which is of type function1 string unit.
And so expect and report are analogous to run.
Yes, right. I didn't put the other two on the slide, but they're very similar.
Okay. All right. Thank you.
Sure.
Have you played around at all with because you can use the reader monad to more or less do the same thing, and just the issue with explicitly passing parameters is that it's annoying to have to plumb that through all of your functions, but I mean that's kind of exactly what the reader monad is.
Yeah,
doing.
on this slide where I have the dynamic variable solution, I have it as only partly clean because it's not type safe. So there's nothing that's preventing me from violating the stack discipline in various ways. So there are different solutions to this that are more pure functional. One of those is the reader monad, which would be the subject of a whole other talk. But it's definitely one of the other solutions for this. Okay, I have one of my extra slides is. Yeah, so if you're interested in the reader monad, check out the implementation of it in Scala Z, and I think there's also, I think Tony Morris also has a blog post where he presents a standalone version. And the implicit parameter solution that I showed, it's also a competition for this, and it actually is type safe. The downside is that it's still somewhat verbose. So that's there's trade-offs of verbosity versus type safety and so forth. You have to make your own decisions on. Okay, thanks.
Thank you.
Let's take a 5-minute break.
Perfect.